Can tin whiskers be prevented from short-circuiting electronics? Imagine tiny metallic hairs growing inside your electronic devices, silently threatening their operation. These are called tin whiskers, and they can cause serious problems. Tin whiskers are hair-like filaments that grow from tin-plated surfaces in electronic parts. They can bridge tiny gaps between conductors, creating short circuits. This can lead to device failures, intermittent glitches, or even failures in extreme cases. Preventing these whiskers from causing harm is a big challenge in electronics manufacturing. The rise of lead-free solders, driven by environmental rules, has made the problem more common. When manufacturers switch to pure tin finishes, the risk of whisker growth increases. These whiskers form because of internal stresses in the tin coating or solder joints. Mechanical stress, temperature changes, and contamination can all trigger whisker growth. Unlike other tiny growths called dendrites, whiskers can grow without any voltage or moisture. They just appear spontaneously. To reduce the risk, companies often use lead-alloyed tin solder, which contains more than 3% lead. Lead helps relax internal stresses and keeps whiskers from forming. But environmental laws restrict lead use in many products, especially consumer electronics. In high-reliability fields like aerospace or medical devices, leaded solders are still common because they are more dependable. Improving plating processes and applying heat treatments can also help. Proper annealing reduces internal stresses in the tin coating. Applying protective coatings like acrylics, epoxies, or silicones over tin surfaces can physically block whisker growth. These coatings act as a barrier, preventing whiskers from bridging gaps. However, coatings do not eliminate whiskers completely. Keeping the assembly clean and free from contamination like iron particles can also help. Iron particles can trigger whisker growth, so thorough cleaning is important. Good design practices matter too. Minimizing mechanical stress, reducing thermal cycling, and designing circuits to tolerate or detect whisker-induced shorts can prevent failures. Testing is vital. High-reliability electronics undergo extensive testing to identify components prone to whisker growth. This includes stress tests and long-term reliability assessments. Despite all these efforts, tin whiskers remains a persistent issue. No single method guarantees complete prevention. Instead, a combination of strategies is used to manage the risk. Understanding how microscopic material behaviors can cause big failures helps us improve product reliability. Recognizing the potential for whiskers to grow and cause shorts is key to designing safer, more reliable electronics.